Hi guys, here we go again. Let's do another problem with a rational function. We're going to figure out what is the oblique asymptote. So we know it's an oblique asymptote because we're being told that we're going to find what it is. But if we didn't see that mentioned there, we should know that it's an oblique asymptote because the function has a degree in the top which is greater than the degree in the bottom by 1. So that does mean that it will be a slanted asymptote or an oblique asymptote rather than a horizontal asymptote. And then B, we want to figure out where the function intersects its asymptote, or even if it does. It says, where does the graph of the function intersect its asymptote? It's asking us where. So I'm assuming that it actually does intersect. And then as x approaches infinity, does the graph of the function approach its asymptote from above or below? Okay, so let's start by doing the division. It says, well, we don't even have to do the division. What a nice problem. It tells us right here what happens when we divide this polynomial divided by this polynomial. It results in this quotient. The oblique asymptote has this as a remainder, and we can disregard that so that we know that the oblique asymptote is y equals x plus 2. And there was a choice to say there is no oblique asymptote, so I guess it's possible that it could have been not an oblique, but turned out to be so. And again, because 5 and 4 differ by 1, where the top is higher. The graph of the function intersects its asymptote at x equals what? Right, so let's see if this function intersects with its asymptote. So if they intersect, they share a point. So if we set them equal to each other and solve for x, we'll figure out which x value they share. And so let's do it. Let's put x plus 2 equal to the function x to the 5th power plus 2x to the 4th power plus x squared plus 4 over x to the 4th plus 2. All right, let's make this a proportion. I'll put that over 1. We'll cross multiply. And so I'll get on the left, I think I'll go this way, so that I have x plus 2 times x to the 4th plus 2. And on the other side, 1 times this. And then we want to figure out when they will be equal. So first let me FOIL this out, or multiply it, distribute. X to x fourth is x to the 5th, plus 2x, plus 2x to the 4th, plus 4 equals x to the 5th, plus 2x to the 4th, plus x squared, plus 4, and this cancels. This cancels. This cancels. So then we have left over just the 2x and the x squared. So this 2x equals x squared. Let's set that equal to 0. So we have x squared minus 2x equals 0. Factor that and set each factor to 0. We get these two places. So at x equals 0 and x equals 2, the graph of f of x, the function, will actually intersect its slanted asymptote. So at 0 and 2. Okay, so it says, does the graph of the function approach its asymptote from above or below as x approaches infinity? All right, so the way to figure this out is, first let's draw a sketch of the oblique asymptote through the y-intercept of 2 with a slope of 1 over 1. So it looks something like that. And there's like a dashed line there. And then the function is going to behave a certain way as x approaches positive infinity. So positive infinity for x is this way. So if I'm approaching the asymptote in that direction, what kind of behavior is happening? It says, does the graph of the function approach its asymptote from above or below as x is approaching infinity? Does the function approach its... Oh, so from above. It would have to be. It would have to be above. Right? Because it's slanted in that way. If I'm approaching it, if I was approaching x equals negative infinity going this way, I would be approaching the asymptote from below. But I'm approaching positive infinity this direction, I would be above. Right? So drawing the sketch is kind of essential there to figure it out.